Hello there and welcome to another topic of module 3. We will be studying reverse polish notations in this module. So a stack organization is very effective for evaluating arithmetic expressions. Mostly common mathematical methods of writing the expression where we have the operator in between two operands is usually difficult for a computer to comprehend and to evaluate. So the common expressions are then written in infix notation. The common expressions are written in infix notation with each operator between the operands, such as this: a plus b. The prefix or the Polish notation is when the operator is before both the operands, and the reverse Polish notation is where the operator is after the operands. The reverse Polish notation is a form that is suitable for stack manipulation. So the expression a multiplied by b plus c multiplied by d can be written in reverse as ab multiplied cd multiplied, and then their products are added together. So in order to solve these reverse Polish notations using the computer system, we are going to scan the expression from left to right. Whenever we reach an operator, we perform the operation with the two operands found on the left side of the operator. Then we remove the two operands and the operator, and instead of that we replace the answer that we get from performing the operation, the result, we replace it with the result, and then we continue to scan the expression and repeat until every operator has been encountered and there are no more operators in the expression. So if we consider the arithmetic 3 into 4 plus 5 into 6, the reverse Polish will be 3 4 multiplied, 5 6 multiplied, and then the addition. This can be implemented using a stack. So we are going to push the operands into the stack, and then whenever there is an operator, we are going to pop them from the stack, we are going to perform the operation, and then we're going to put the result into the stack. So when we have 3 and 4, so first we push 3 and then we push 4, so the stack pointer points to 4. Once we come across the multiplication, then we are multiplying and getting the product of 3 and 4, which is 12, which is stored, and then now we push that onto the stack. At the next step we encounter 5, which is pushed into the stack. We see 6 again, pushed again to the stack, and then multiplication of the top two elements. You cannot take the bottom one because the top two elements are used. So 6 into 5 gives us 30, and then we finally encounter the last operator, which is addition. Their summation gives us the final result, and hence this is how we can solve the expression using stacks and the reverse Polish notation. So each box represents one stack operation, and the arrow always points to the top of the stack, that is the top experiment, the top value in the stack, and then we scan the expression from left to right. Whenever we encounter operands, the first number 3 is pushed onto the stack, then 4 is pushed on the stack. As I explained, multiplication happens, the result is placed back. We encounter 5 and 6, they are pushed onto the stack, then they are multiplied together, and then finally we get the final sum as 42 after all the operations have been performed. Here are some questions that you can solve. Similarly, you are going to create a Polish notation. So a multiplied by b plus c into d plus e into f. This will give us the Polish notation of a b multiplied, c d multiplied, and then plus, and then we'll have e f multiplied and then plus, and then we can solve them using the stack. You can solve these questions and find out the answers. Okay, thank you and see you in the next topic.